Hello and welcome to 9.4 Notes. Today's notes is on rotations, and recall that a rotation is a transformation in which a figure is turned about or around a fixed point. And that fixed point is called the center of rotation. So rotations can be clockwise or counterclockwise, but in this chapter all rotations are counterclockwise. So all rotations in this book will be going in this direction. With one exception as far as what I can tell, and I'll show you that exception in a bit. I believe the book made a mistake, and before the end of this lecture I'll show you what I mean by that. But as far as I can see, there's only one exception to their rule that they made up, and like I said, I'll go with that. So for the most part it'll be in that direction. If not, you know, they'll have an arrow and it'll be pretty clear. Alright, so moving right along, here is an example of a rotation, and I copied that onto the next frame. So again, here is an example of a rotation. So if you have the original figure A, right, this point here is figure A, now we will rotate it 130 degrees about the origin, which is this rotation, 130 degrees, and it's about or around the origin, right there, the center, the point 0, 0. Okay, so that's a 130 degree rotation about the origin, and we have the original figure A, or the preimage A, and it turns into the image A prime. Okay, we call that A prime. Alright, there are coordinate rules that can be used to find the coordinates of a point after rotations of 90 degrees, 180 degrees, or 270 degrees about the origin. And remember, at any point in this presentation you can pause it and write down your notes at your leisure. Rewind, do whatever you want. You're in total control of these presentations. I'm going to continue. These are the coordinate rules for rotation about the origin. When you have a point A comma B, and it's rotated counterclockwise about the origin, the following are true. For a rotation of 90 degrees, AB becomes negative BA. So if you had, say, the point 1, 2, it would become negative 2, 1. Okay? And then for a rotation of 180 degrees, AB becomes negative AB. So if you had the point 3, 5, then that would become negative 3, negative 5. And then finally, for a rotation of 270 degrees, AB becomes B, negative A. So if you had, say, 6, 7, then it would become 7, negative 6. Okay? So, moving right along, graph triangle JKL with vertices J is 3, 0, K is 4, 3, and L is 6, 0. Rotate the triangle 90 degrees about the origin. And I just copied the prompt onto this next frame so we'd have some room here. So here's my coordinate plane, and I'm going to plot point J, which is 3, 0. And that's what I've done here. And then next I will plot point K, which is 4, 3, and then I will plot point L, which is 6, 0. Okay, so that's the point L. I should probably label that. Okay, that's point L, which is point 6, 0, and then I drew the triangle. So that's my preimage, JKL. And after a rotation of 90 degrees, remember AB becomes negative BA. So working with that, J, if J is the point 3, 0, then this would be a good exercise for you to just pause this presentation and make a prediction as to what you think negative BA would be. But for the sake of this presentation, I will continue. So if you have 3, 0, and you're rotating at 90 degrees, and it's going to be negative B. Negative 0, of course, is just 0. So that's where you get that 0 from. And then the A moves over here, so it's going to be 3. Right? It just gets switched. So you have 0, 3. 3, 0 becomes 0, 3. And then K, if K is 4, 3, then K prime is going to be negative 3, and then you just move the 4 over, so negative 3, 4. So remember, it's you go from A to B, and then, or excuse me, you go from A comma B to negative B comma A. So if B was 3, then the thing that goes in this position is negative 3. Okay, so that's where you get the negative 3 from. And then you would have negative 3, 4. Okay? And then moving right along with the L. If L is 6, 0, then L prime is going to be 0, 6. Okay, so I have now my J prime, K prime, L prime, and I will plot those points. So there's my J prime of 0, 3. Here's my K prime of negative 3, 4. And here is my L prime of 0, 6. And then connecting them, and that's my image, rotated 90 degrees about the origin. So that was 90 degrees. Moving from here to there was a 90-degree rotation about or around the origin, which of course is the point 0, 0. Okay? And remember that a rotation is an isometry, so it's the image will be the same size as the pre-image. And so we can do problems like this. Find the value of r in the rotation of the triangle. So this was that one exception that I have found in the book. I believe it's a mistake, because in the book on page 598 it tells you that all rotations are counterclockwise for this chapter, but then they give you one here that's actually clockwise. And as far as I can tell, this is the only exception. And over the years, it's been the only exception that students have brought to my attention, so I think we're kind of good to go in that respect. So we're actually going from this green image, 110 degrees, to this red image. And so to kind of tell you what's going on, after you rotate this 110 degrees from the pre-image to the image, then you get that 2s is equal to 12, and therefore s is equal to 6. And then you also have that 2s plus 3 is equal to 3r. So I'll kind of explain that. Let me see if I can do that. Bear with me here. Okay, so I have this, and if I can, this might be hard to do because it's going to change size. I can't prevent it from doing that. But if I take this figure and if I rotate it 110 degrees, becomes like this, and it matches up here. And like I said, it changes size, but I can just get the correct size. Again, bring it back to the correct size, and there you have that the 2s is equal to 12, and the 2s plus 3 is equal to 3r. So that's where you get that from. Hopefully you can kind of visually see that there. Okay? So again, if you move this 110 degrees, then the 2s side matches up with the 12 side, and the 2s plus 3 side matches up with the 3r side. Okay? So moving right along with these equations, you have 2 times 6 plus 3 equals 3r, right? I'm substituting s equals 6 for s in there, and I'm getting 2s plus 3 equals 3r, or 15 equals 3r. Divide both sides by 3, and you get 5 is equal to r. So find the value of r in the rotation. R is equal to 5. Okay? And that's the end of the presentation. As usual, if you have any questions or concerns, always feel free to contact me at your convenience, and it would be my pleasure to help you. Okay? Bye-bye.